Hi, GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
Hello everyone, welcome to Google Drive Live. My name's Ali and I'm joined today with Steve.
Hi everyone.
And today we're going to talk to you a bit about the differences between Google Drive and a conventional or traditional file system as you would have on your hard disks at home. We're going to explore a range of topics, mostly based around the use cases and why you'd want to look at it this way.
Yeah, I've gotten this question from a lot of developers. Some who are just looking to integrate with Drive from a fairly straightforward integration, but are just new to the model that Drive has. But there's also some really cool use cases with like sync clients, virtual file systems, all sorts of things people can do.
So should we just talk about them very briefly? What do you mean by a virtual file system?
So I know there's actually an open source project that somebody's done, started working on. It's a fuse adapter for Drive, basically to make Drive look like a local file system. Personally, I actually started playing around with doing this with the HTML5 file system and see if I could do a shim that makes Drive appear like any other file system in JavaScript.
Cool.
And I don't know about sync clients, but rumor has it you were playing around with one?
Yeah, so a sync client is essentially an application that runs on your local machine that mirrors what's in Drive. And that's another use case for this. And really, any situation where you're using a conventional local file system, you should consider what would happen if I swapped out the local file system and replaced it with a cloud file system like Drive. How would you go about doing that?
So what do you think some of like the bigger, before we go into some of the challenges, what do you think some of the key differences are with Drive and a regular file system?
Well, my favorite one is that you can run out of hard drive space, but you can never run out of Drive.
Well, that's not entirely true. There's quota.
There's quota.
You do have to pay for it.
Exactly. But that's my favorite one. But apart from that, the structure is slightly different. Anything you want to say about?
Well, probably the biggest one is paths, right? I mean, everything in Drive is really identified by a unique identifier. It's basically a UUID for that file, as opposed to a path like you would have on a normal file system. So that does create some challenges when you are expecting it to behave like a file system.
Right. So does that mean all your files are flat and they have an ID?
No, not. We do have parents, which you can basically they're labels, but we present them like folders in the UI. And parents could be inside other parents, and you can build up path-like structures. But the concept of path addressable files is something that is missing in Drive compared to a normal file system. So if you wanted to look up a file by /who/bar/ myfile.txt, you have to do a little bit of work. Right.
So okay, first use case. The standard thing you want to do with a file system, say you have a directory, a folder with some files, and you want to list them. Something.
Generally pretty straightforward to list. I mean, it's basically files.list in the API. But file systems have some different rules than what Drive has. The biggest one that comes to mind is the fact that file names in Drive don't have to be unique.
Right.
So you have to basically if you require file names to be unique because you're trying to impersonate a file system, you have to figure out how do you disambiguate two files with the same name.
So any thoughts on that? How would you go about doing that?
Well, I know. For example, the sync client that's available with Drive uses, I believe, the file creation date. In the case that it detects two files with the same name, it will append to one of them the creation time. Now, it's nice because it gives you a nice stable ID that's not going to change in between, new files getting added and so on. But when I was playing around the file system or doing this in JavaScript, I did run into a few issues with that, though. It's actually not quite as simple as it sounds.
Like what kind of issues?
Well, so one of them is if you take a look at like the HTML file system, for example, it encourages paging. And so when I was first approaching this, I thought, well, I'll just take pages from Google Drive as I get those results, and I will, just call the callback every time I get a new set of results. That I can keep doing this and have a nice responsive API. The problem is, in order to do the disambiguation reliably, you really want to make sure that the files are always going to be returned back in the same order. Because if you're doing this on the fly, you can certainly keep track of all the ones you've seen, and the next time you get a duplicate, change that name. But if the files come out of order, every time the user refreshes, file names are going to come back, and sometimes file A will have the timestamp, sometimes file B will have the timestamp, and it can get kind of confusing.
I see. So I had this similar problem when trying to write a client that simulates synchronizing like this. I actually opted to disambiguate just by adding a 1 or a 2 in brackets.
But you still have the same fundamental issue, though. So you want that name to be as stable as possible.
Exactly. Yeah. So I ignored the fact that it could be stable. I said, okay, well, I'm not going to win there. Instead, I'll have to store a set of metadata myself in a database which says the absolute path on the local file system and the ID of the file on Google Drive. And because of that, it means, well, either can change and it doesn't matter because I won't lose track of what's happening.
Exactly. And that is an option that I was looking at on the JavaScript side, as well as using local storage or something as a cache, so I can keep track of some of this data in something that's persistent to that client. So at least in between directory calls, even if the files change order, I can still map them back to the same name. So it actually, if you have the option of local storage, that actually works out to be a pretty nice solution.
Yeah. And if you don't have that, well, then it's going to be a bit tricky, I guess.
Yeah, you end up having to, either you do what you said, you just don't worry about it, or you have to do things like, buffer up all the results, fetch all your pages, sort on the client side, and then you can make sure that you have a stable name that way.
So this is
bit of extra work.
This is one of our big fundamental differences, is that you get all the files in a file system you can get them at the same time, but you have to use paging in Google Drive.
Right. Otherwise, because it is a remote service, it is the response time is significantly longer than if you were doing this on a local file system. So paging is really important if you want to have that user responsiveness, where you can return back the first 50 results or so very quickly, and then as the user continues on, keep fetching. If you try to batch up 2,000 file directory, you're talking several seconds of wait time.
Right, which leads us on nicely onto the next point, is that when you're developing for a local file system, you can really assume that your calls are going to come back almost immediately. Not really immediately, but almost immediately. So a lot of local file system programming just involves synchronous calls that blocks until it returns, and you imagine that actually that's not really going to take too long.
Right, exactly.
With Google Drive or any remote file system, really you have to build this into whatever you're doing. You have to put it into the core, and it has to be asynchronous. So you have to say, go away and do this, and then when it's done, tell me about it, and I'll do something there.
Yeah, exactly. And that was another case where it was actually easier when trying to do the file system in JavaScript, because that API is asynchronous. It was a very nice match. There is actually a synchronous version of that API that I didn't even attempt to try, just because trying to do that and make this inherently asynchronous process appear synchronous was too much work for what I was trying to do at the time. And mostly just an experiment.
Really important for graphical applications, because usually these things run in a single thread by standard, and if you want to block that thread, you're going to block everything. Right. The hover buttons aren't going to work, and menus are going to crash, and windows are going to go that nasty grey color. So really, really important here. And modern operating systems, Android specifically, it won't let you make blocking calls like this. Yeah, so you really have to bake it in from the start.
Yep, definitely. So another area that was less important for sync clients, more for virtual file systems, if you're doing a fuse file system or anything like that, it is file paths. So there's really just one thing that's just not in Drive is the ability to address a file via path. And actually, this does relate a little bit to the issue of disambiguation, because in these cases of file name conflicts, we're doing all this resolution on the client side in terms of detecting if two file names have the same name or two folders have the same name, and creating a unique one. Whatever names we assign aren't really known by the Drive server, so we can't address those files with those disambiguated paths. So it does create a little bit of an issue. It's not a lot of work, but you do have to be able to handle that traversal on the client side, be able to resolve parents and so on. But this is also a case where local storage actually ends up being really handy because you can basically build up a cache of paths mapped to file ID so that you can resolve those entirely on the client.
So did you find an elegant way to do the paths, or were you just snipping a bit off at each time and just going through?
So I actually tried a few different strategies. You probably did as well.
Well, I'm interested to know what you did.
So the two strategies I was looking at was basically just traversing with each step in the path. Obviously, keeping track of relative paths as well is really important. But for things that I didn't have cached, it would have to be go and fetch this item, and if it's a folder and there's more path, keep traversing, and it ends up being several calls. Obviously, each part of the path is another remote call, so it actually can get very expensive if you're trying to traverse a really, really deep path. The other approach, which was much more performant, but takes a little bit more to actually set it up and get it to work reliably, was kind of what I mentioned earlier, building up a cache, or basically a mapping of full paths to a file to their file ID, so that as I traverse directories and retrieve files, I would just store that path and that file ID. So if I ever needed to reference it, I could do that. Or if I at least have part of the parent, I could at least shortcut part of that lookup. So maybe I don't have the full path, but I'll at least have one or two of the directories in there.
So you just treat that whole path as a single string, essentially.
Yeah. And do things like prefix matching and so on. But ways that you can save a little bit of work. But again, a lot of that requires doing either kind of building it up on the fly, in which case you have to deal with misses and try to traverse it anyway. Or another thing I was looking at was combining the changes feed. So basically doing one upfront huge query to basically build all the paths, and then using the changes feed to keep up to date. So if things get moved around, then I can just update that without having to query a folder every time that I wanted to get its content.
So the changes feed is one of those nice things that we have more features in Google Drive than a regular file system, and obviously we can keep adding features to it, whereas a file system is pretty much something that is there and it's not really going to change.
It's a really useful feature for for these types of cases, particularly sync clients. I mean, it's the heart of a sync client. Is the changes feed.
Yeah. So how the sync client works is, it's two-way. The first one, we have to monitor changes on the file system, and the second one, we have to monitor changes in Drive. Now, you can do changes on the file system. The different operating systems have very much their own specific thing for that, so that they can do that. Windows has its own, Mac OS has its own, and on Linux you use iNotify or something like this. So we have that baked into Google Drive. So it's called the changes feed, and you say what has changed in the user's Google Drive since a certain point in time, and everything that has changed since then is returned. And that's how we were doing it to check changes that have happened then. Obviously there's going to be problems, because if someone changes a file in both places at the same time, what are you going to do in that situation?
Yeah, and that's actually a good question. So so one of the other issues with related to paths and everything is the fact that a file can have multiple parents, and for the most part, at least when I was doing some stuff with the file system, this wasn't a huge problem, right? It's not that much different than having, say, symlinks, for example. Just a file happens to exist in two directories. I imagine, though, for the sync client, that's probably a little bit more of a challenge, though. There might be some edge cases probably really rare edge cases, but things where you have concurrent edits of the file locally, then you have to resolve those.
So I mean that is a problem, really. Which one wins? Who is the real file and who is the symlink? So just to go over multiple parents, as we have in Drive, just to explain that properly. A file can be in many different folders at the same time, and Steve mentioned it. They're just labels. They're just like tags or labels, and you can put them in as many as you like. So when you synchronize that down to the local file system, which one is a copy, which one is the actual file? I actually solved it by putting a copy of the file in both places.
Right.
And then if the file changed in either place, I would update it remotely and in both those locations. I'm not sure that's the greatest solution, to be honest.
And in which, so if you had two near simultaneous edits,
right?
Which one would you take? Is it last in?
Yeah, the last in.
So basically the same as doing a resolution against a remote copy as well.
I mean, how the sync client works is it tries on that very level of disambiguating. It tries to run it all in a single queue so that you never get race conditions there. So the last one would win because it would just happen after the more previous one. Not ideal, and that's why my sync client was just a learning experience or something like that. It's the real Google Sync clients spend a lot of code trying to handle these cases like this.
So one of the cases that comes up, I know I've talked to a couple developers who've written their own sync processes and so on, is timestamping. It's actually really important in terms of suppose you have a local edit on the file, making sure that edit time is reflected in Drive instead of the upload time. And is that something that developers can do if they need to make sure that edit times and creation times?
I think the creation time is set, but the edit time, I think you can set that yourself. Yeah, you can override that. I'm not exactly sure by that. But yeah, that is really, really important. So you want to know when the file was last edited actually by a user, not by the last time it was uploaded to our server.
Right.
So useful use case. And we offer other ways of finding out has the file changed.
Right. That's like the MD5 hash.
The MD5 hash, exactly.
Yeah, very, very easy to calculate. So a good way to check, did the metadata change, or is this actually content that's fresh and needs to be downloaded? So are there anything else that you can think of, or?
Well, I can really only think of advantages of things that Google Drive has that a local file system doesn't have, such as we have all this additional metadata that's amazingly useful. Obviously, on a file system, you have the name, you have the size of the file, you can get the permissions. That's pretty much it without using third-party tools to do stuff. But we store things such as the extension of the file, the MIME type of the file. That can be an absolute nightmare to work out yourselves. The MD5 hash, as you mentioned. And then we have ways in which you can convert the file or export the file, or look, if it's a video, for example, stream the file immediately. The kind of benefits you can only really get from a cloud file system.
Actually, that does raise something. Is there are certain files in Drive that aren't really files, right? So there are things like Google Docs, a presentation, spreadsheets,
folders,
shortcuts for third-party apps that everyone out there is building. How do these behave differently?
Well, there's no binary content in these. So by binary content, the file data, there's nothing there. So a folder is just a placeholder with a specific MIME type so that we know it's a placeholder and it can be used as a parent. And the more interesting cases are these links. Some of them are Google Docs and some of them are third-party linked files. So what do we get in that situation? Well, all you can put on the local file system is a URL to the file.
Right.
Now what could that URL do, for example? It could open up the file in the remote application, in the third-party application, or in Google Docs, Google Spreadsheets. We could probably do a bit better than that, couldn't we? What do you think?
Yeah, they probably could. So one of the issues that we, with the current way it works, has to do, I think, with our OAuth implementation, the way that we initiate the process. It's not really friendly right now to offline access.
Right.
There are cases where, like one feature I would love to see is almost like shadow documents, where it's like you could have the content in a third-party system, in a database, but, quietly in the background keep data up to sync. So you always had that export, you always had that binary data that you can download and use locally. You can use it offline. Something like that would actually be kind of cool. But as it is now, I mean, the URL feature works pretty well because you can, click on one of these .glink files, open it up in a browser, and use the app. And launch it from the file system just the same way as if you launched it from the Drive UI. So it's pretty cool the way it works. Right?
I mean, that's really nice in the case where you don't have a native editor. And by native editor, I mean something that will run on your PC or your Android or whatever.
Right.
So if there is a native editor exists, say for example, I don't know, a text editor that you can run on your local machine as well, you'd probably like to use the local version. It just would give you a better experience. And these days, still, unfortunately, native apps sometimes do feel a bit better than web apps.
Yeah, and this is a criticism I've heard of even our own editors. So, for example, having a Word doc in Drive, in order to edit that in our document editor, it has to be converted, but then you lose that ability to sync those changes back into the binary representation of it. So having a little bit more seamless support for switching between the binary file for local or for native apps, and then the online only more collaborative version for when you're on the web, that would actually be
So
an ideal
that's
case.
something I'd really like to see there.
Also a really hard technical problem.
Yeah,
to
really,
solve.
really hard. It would also solve a lot of the offline issues.
Yeah,
Say
exactly.
you lose web access, that might be
so,
something that would be really useful.
Yeah, something that we can certainly suggest to the engineering team. But I know that there's been some conversations, and it's not the easiest thing to tackle.
Especially since there are so many platforms.
Yeah,
and,
exactly.
Sometimes you'll find an app that's available for all these platforms. Which one should you launch? The authorization issue, as you mentioned, that's also huge.
Yeah, and it's also very hard to do this in a way that's not lossy. Every time you do a conversion between these formats, there's always that potential that there's some item that's not going to map well. So you really want to just do that once, fix the issues that you run into in terms of the conversion, and then work in the new format. So it's a nice to have thing, but it sounds really, really cool. In practice, it's probably a little limited, and so we'll see how it goes though. Be cool to try at least.
Yeah, definitely. So should we just summarize what we've been over?
In terms of should people even be building sync clients and virtual file systems? And I would say, if you can. I
would say strongly yes. Why not?
Yeah, especially a virtual file system, I think is actually something that's has some good practical uses. With you see a lot of apps like these Windows virtualization machines in the cloud where you can run native apps through remote desktops. Those are cases where it doesn't really make sense for them to try to sync everything in Drive, right? Especially when they have these kind of very ephemeral, machines that come and go and they get spun up and spun down. Virtual file system is perfect for that case. And custom sync client is there's probably a lot of value that you could add if you have a good idea.
Yeah. So already there are a number of custom sync clients out there. They're all slightly different and they approach things in a different way. I hope we got across that it's actually technically quite a tricky problem. So each one has their own benefits. There's one that's targeted for OS 10. There's a Linux-based one. There's various ones, and I advise you try them out, read their code, because it is useful, and they will have had to solve some of these problems.
Oh, definitely. But yeah, it's a really fun problem to solve. Hopefully,
if you like that kind of thing.
I like it.
Yeah, me too.
I think it's actually really fun trying to solve these problems. But then even if you're not not doing anything like that, but you're just new to Drive and trying to just get your head around its model, it's useful to understand these differences.
Yeah, absolutely. So what have we talked about? Well, we spoke about the use cases. Why would you want to do this? Why would you want to treat Drive as a local file system? And how that would be. The key difference is, well, Steve mentioned paths. We spoke about multiple parents and the non-uniqueness of file names and how you would deal with those things. And we spoke about some of the challenges involved in that.
Right, especially around disambiguating the file names and resolving paths. There's a lot of different strategies that you can go around to address those, depending on whether or not you have you're building a sync client or a virtual file system, and if you have local storage that you can use to cache some of that data. Lots of different strategies, and you just have to kind of look at your particular use case and what you're trying to accomplish. But none of these are I would say insurmountable problems.
No.
They're little small things that you have to kind of deal with, and they add a little bit of complexity, but generally things that you can solve with just a little bit of forethought and tiny bit of code.
And we mentioned the asynchronous nature of Drive and making web requests. Probably we concluded that whatever you're doing, you should do this asynchronously anyway, even for a local file system, because that would make your app more responsive, and users love responsive apps.
Yeah, it's a little, for people used to using blocking calls in their web apps, yeah, it's a little bit harder to do, but it's worth
it's worth it.
Worth doing.
And I guess finally to end on, we're really keen to see what you're writing. So if you're doing one of these cool apps, you might think it's not exactly the use case for Google Drive. You might think we don't want to know about that. Actually, the more interesting and strange your app is, the more likely we are that we do want to know about it.
But it has to be good, interesting, and good, interesting.
Good, of course, good, interesting, not bad, interesting.
Yeah, and definitely encourage everyone. If you are building an app, whether it's something that is like this, or just something just a regular web app that's integrated with the Drive UI or whatever. You can find us on Google+, find us in Stack Overflow. But reach out and let us know what you're building.
Ask those difficult questions.
Yeah, especially in Stack Overflow. And I think the response time has been really great so far in getting answers out there. But since I'm the developer advocate and tend to do a little bit more one-on-one, I'd love to get an email or put something on Google+ to just let me know what you're doing and see what we can do to help.
Great. Thank you. Good luck with everything.
Great. Thanks, everyone.
Bye-bye.